All right, we're going to talk about the joiner now. We have two joiners. We have an 8-inch joiner and there's a 12-inch joiner over there. The reason these are called 8-inch and 12-inch joiners is because the width of the cutter head on each is that specific dimension. So this has an 8-inch wide cutter head, and what we do with the joiner is we use the joiner to prep a face and prep an edge. The whole purpose of this machine is to get a face nice and flat and an edge nice and straight. With a flat face and a straight edge, we can go to the other equipment in the shop and get another edge that's square and another face that's parallel. So we can, this is a prep machine that you're going to have to run every single board you use on here. So to take a little bit of a look here at the joiner, okay, you can see the cutter head is below the table, and you're going to pass the board over top, and it's going to shave a thin layer off, making this flat or straight. We may run into a situation where you're going to have to move the fence to make sure that the entire width of the board can be accommodated. That is this lever right here. All you do is move it to the left, and then you can slide the whole fence in and out. We want to make sure that the entire board will be cut. We don't want to have the fence out like this so that we're missing an entire chunk of the board. So I'm going to move the fence and I'm going to lock it. That's it. You don't need to crank on it. You don't need to hit it with a hammer or anything like that. Just a little bit of hand pressure. Now, how do we know which edge to joint or face to joint? We have to find or locate the concave surface of our board, because that is the one we want to clean up. If I put this board down on the table and you look at the end, you see the gap in the middle, but it's touching at the ends here. That is the concave side. If I flip this over, okay, now the concave or convex side is down. The problem with that is this board rocks, so you're never going to get a truly flat surface if you try and joint this way. We want to flip the board over, put the concave side down. Now you can see I can't wiggle this, okay, because I'm supported on two different sides by the board. So what I'm going to do now is I'm going to take a push block and a push shoe. Okay, the push shoe's got a little lip on the bottom that's going to hook on the end of the board and push this through. The push block is going to go on the front and help me keep the board pushed down onto the table. We never, when face joining, want to try and just use our fingers. Okay? If I try and do this by hand, my hands and fingers are way too close to the machine or the cutter. And if I come to the back side here, you'll notice how, because I have to hook onto this board here, how close my fingers would come to that cutter head. All right? So we want to make sure we get our hands up and away, which is why we're going to use the push block and the push shoe here. So I'm going to place them both on here, okay? And I'm going to go ahead and run this board through, making sure I cut all the way through. It doesn't take a lot of pressure. Okay? We just kind of want to let the weight of our arms and the board and the push blocks do the work for us. So I'm going to turn it on, and I'm going to pass this board through one time, and then we'll regroup. That cut this surface. Now we're going to look and see if it cut it enough to make that flat. Okay? You can see there's still a little bit of a gap there. So what I would like to do is to ensure that I cut the entire surface, I might take a pencil and scribble across the entire surface. I'm going to face joint this side again, and I'm going to continue to face joint it until all of the pencil marks go away. It might be one more pass, it might be two more passes. We'll just have to see. You can see almost all the pencil marks are away. I might do one more pass to clean up that last little bit of pencil mark, but if we look now, we're pretty close to being flat on the table. Okay? That board would probably be good to move on to the next step, but again, with this still being pencil mark, it might be worth doing one more pass on the face joining. So face joining often needs to happen. Okay, you can see this board is still gapped at the table. If I grab another board and put it down here, you can see it's already pretty flat. And at this point, I would say that this particular board doesn't need to be face jointed. It's flat enough to begin with. We just have to remember that this is the flat side when we go to other pieces of equipment. So you might want to put a mark, an R for reference, or a REF for reference, or an X or a check mark. Something for you to remember that this surface is already flat enough for future work. The other big use for the joiner is to get a straight edge. Now, just like with face joining, we want to look for the concave edge. If I put this edge down there, it looks pretty flat. This end comes up, so this might actually be convex. If I flip the board over, okay, you can see there's a big gap at the table. That is my concave side. That is the side that I'm going to do all of my cutting on. Now, to edge joint, we're going to take a flat face, place it against the fence, and we're going to run the board through that way. The fence becomes our reference plane, not the table. Okay? When we face jointed, the table is what we were worried about. When we edge joint, okay, we're worried about this fence. Now, we want to make sure that this edge that we joint is going to be square or perpendicular to our reference face. So it's always a good idea to grab a tri-square, place it on the table, and line it up to the fence and make sure that you don't see any light there. That tells me that the fence and the table are perpendicular to one another. As long as I keep my board tight to the fence, the ensuing edge should be perpendicular to that face. Now, a couple of things. We don't need to use push box and push shoes for this operation. However, you see this caution sticker here? We want to try as best as we can to avoid passing our fingers through there, because the cutter head is directly below there. If I'm in the midst of a cut and this kicks back while I'm pushing down, I run the risk of pushing my hands down into that cutter head. So I've checked my fence. I've got my concave side down. I'm going to go ahead and cut this. When I'm cutting, I'm going to put my left hand on top, my thumb on top, pushing down, my index finger pushing into the fence. I want to make sure that there is no gap between the board and my fence. I'm going to leave this hand in place, and my left hand, or my right hand, excuse me, is going to push down my thumb and through with my hand. So this is going to stay in place, and I'm going to feed this through. When I have enough material over here on the outside of the sticker, I'll move my hand over, and complete the cut. Okay, so reference face against the fence, left hand on the board. Now you hear it cut at the beginning and cut at the end, but it didn't cut at the middle. What we're doing is we're slowly nibbling away here, and then we'll nibble away here and here again until we end up cutting the entire surface. So this is still concave, so I'm going to continue that cut until I end up with this nice straight edge again. So that board took 3 passes to go ahead and flatten or straighten. Some might take 1, some might take 4, some might take 6. You're going to keep going until you have a nice straight edge. All right? There's no reason for me to continue to cut right now because I already have a nice straight surface. All right, now that we have face jointed and edge jointed, these two surfaces become our reference surfaces. So I like to put little marks, references, X's, check marks. Okay, I'll put a little X here. That is a visual for me to realize that these two surfaces have already been milled. So whenever I go to the surface planer or the table saw, I know that these surfaces are the ones that are going to get referenced against fences and tables and other guide devices, miter saws, whatever it may be. So let's take a second here and talk about some other safety issues. We talked about where not to put your hands, stay out of the caution area here. Make sure you're using a push shoe and a push block when you're face joining. Kickback on this machine, fairly rare. However, if there is a kickback, the cutter head rotates like this. So as you bring your board in, it wants to hit it, and it's going to want to send your board toward the miter saw over here. So if you're working in the shop, you want to make sure we're not standing in the kickback area. If you're somebody who's working on the miter saw, and you see somebody that you don't trust come up to the joiner, maybe we step away until they're done with the joiner. Now, kickback is going to occur for a couple of reasons. The first reason is you are not backing up your board with a push block or your finger. If I don't have any support back here, okay, there is nothing to keep the cutter head from grabbing and pushing the board back into the kickback area. The other big reason is you're milling or jointing a board that is too short. Okay, we're going to run the boards through with the grain on this machine. Okay, so right now, if I were to joint this board, I'd be running it like this. That is far too short of a board. Minimum length on a board that we can joint is 10 inches on this joiner and 12 inches on the other joiner. If I try and joint a board that's this small, what's going to happen is it's going to tend to want to dip into the gap between the tables. That little dip here is going to cause the cutter to grab this front corner and throw the board out into the kickback area. So we want to pay attention to the length of our stock. We want to make sure we're holding the board firmly, and we want to make sure that nobody is in this kickback area when we're using the joiner. All right, I'd like to kind of explain how the joiner works. It's kind of a little bit of a mystery to some people. The whole reason this works is the in-feed table, which is this table here, is slightly below the height of the cutter. That determines our depth of cut, or how much is removed at one time. The outfeed table over here is set up so that it is exactly in line with the top level of our cutter, so that as I'm cutting, okay, the board is going to end up being two different dimensions. Okay, after it's gone through the cutter, it's going to be a little bit thinner than the portion that hasn't. So the portion that's been cut is held by the outfeed table, while the portion that isn't cut or hasn't been cut yet is supported by the infeed table.